Yeah, welcome to the another question. You're given a very, very important question today we want to solve. You may see there, the mass of a stone is measured to be almost 410 and 10 gram. 410 gram. It is then placed in a graduated cylinder and shown in the figure. You may see this is the measuring cylinder. It is a measuring cylinder. First, see the volume I said to be almost 500 mils. 500 mils. Then if the stone is placed in a graduated cylinder, then the stone is placed inside the graduated cylinder, having the liquid as you see, and the volume of the liquid lies to almost 800 mils. 800 milliliter. So what is the density of the stone? What is very, very important in this question is to do something like this: a data given, solution data given. We have given mass of stone. Mass of stone is almost 410 gram. That is the mass of the stone is almost 410 gram. You may see now we have a volume of liquid. Volume one is almost 500 mils, and also we have volume two is almost 800 mils. We want to find the density of the stone, but we should ask where is the volume of the stone? Where is the volume of the stone? What is very, very important in this question, we need to understand that the volume of the liquid before stone has been has been inserted inside or the placed inside the liquid. The initial volume of the liquid was almost 500 mils or milliliter. But after the stone placed inside the liquid, the volume lies to almost 80 100 mils. What is the cause of this volume to rise? You may find it is because stone is inside. So the difference between this and this is the volume of the stone. So in order to get the volume of the stone, we need to take V2 minus V1. So volume of the stone is almost 80 100 mils minus 500 mils. So finally, we can get the volume of the stone is almost 300 mils or milliliter. So it's very, very important to be familiar with that materials. Then after that, we can find out the density of the stone. Why? Because we know density of the stone from formula say density of the stone is equal to mass of stone over volume of stone. Mass of stone over volume of stone. So the density of the stone is almost 410 gram divided by almost 300 mils, which is actually the volume of the stone we taken from the difference between almost 800 mils, uh, 80 80 100 mils minus 500 mils, so we can get almost 3 100 mils. If you find the mathematical, if you take almost 410 gram divided by almost 300 mils, you can get approximately now the density of the stone is almost 1.4 gram per milliliter, gram per milliliter, or gram per mils. So this is how we can solve important materials in this way. So it is very, very interesting to do this question. What is very, very important in this question is to identify the data. We have given the mass of the stone is almost 410 gram. We have given volume one. It means the volume of the liquid before the stone is almost 500 mils. And also you have the volume 2, which is the volume after the stone. It's almost 100 mils. So what caused the volume to change? It because stone is inside. So if you take the difference between this volume and this volume, you can get the volume of the stone. Finally, you can get the volume of the stone is almost 300 mils. So the question asks you to calculate the density of the density of the water, the density of the stone. In order to get the density of the stone, you take the mass of the stone divided by the volume of the stone. So the density of the stone is almost 410 gram per, or divided by 300 mils. So you can get mathematically is almost 1.4 gram per milliliter of mils. Oh, thanks.